Namaste everyone. In this video, we'll solve a problem here. The problem consists of a pendulum which is resting in this position. And at the end of this pendulum, we have a bob of mass 2 kgs. We are hitting this bob, which is stationary initially, with a bullet which is moving at 100 meters per second. And we have been told to find the height to which this bob will raise, in two cases. The first case is the one wherein the bullet gets embedded in the bob, which means both the velocities will be equal. And second is the case wherein the bullet is escaping with a velocity 10 meter per second. So that will be the point B. Let's go ahead and first solve the first bit of this problem. So the given data here is going to be M1, which is the mass of the bullet, that's given as 10 kgs. So we just need to convert this into, this is given in grams and we need to convert this into kgs, which turns out to be 0.01 is the initial velocity u1 for the bullet, that's 100 meters per second. Then the mass m2, which is of the bob, that is given as 2 kgs. The initial velocity of the bob, however, because it is stationary, this is equal to 0. The final velocity v1 of the bullet and the final velocity v2 of the bob, they are both equal. So they are both to be equal. So this is the given data, and with this data, we should first be able to find the final velocity of both objects. Once we know the final velocities, we can use the potential energy and kinetic energy relations to find by how much height this is to increase. Fine. So let's go ahead and apply the conservation of momentum principle over here. The conservation of momentum principle tells us that m1 u1 plus m2 u2, which is the total momentum before collision, that's equal to m1 v1 plus m2 v2, which is the total momentum after collision. The total momentum of any isolated system of bodies will remain constant. That's what the principle of conservation of momentum actually tells us. Let us substitute all the values that we know. 0.01 times 100 meters per second, and m2 is 2, and initial velocity of that is 0, so that's equal to m1 again 0.01 times v1 and v2, both are equal, so let's take them equal to x. So let's go ahead and take x plus m2 is equal to kgs. The velocity is here as well, is equal to x. We can see x is the only unknown here. Let's find the value of x. We see here that the value we get is 0.5. This is the final velocity of both the bullet as well as the bob together. Now with this velocity, we have to find how much height it's going to rise. So this is the height that we will be able to find. Let's use the kinetic energy and potential energy relation. So we just have to take the kinetic energy to be equal to the potential energy. We know the formula for kinetic energy, that's half mv square. So the mass is the total mass of both the bullet and as well as the bob, and that we have to multiply with the final velocity square. And potential energy is m into g into h, m again being the combined mass of both the bob and the bullet, and into g into h is what we are interested to find. M1 plus M2 gets cancelled on both the sides, and we get h value as equal to x square divided by 2g. So let us substitute it and find the value. You can see here in the calculator that when we do the calculation, we are getting that value as 0.012 meters. Actually, when we round it off, we get 0.013 meters. Ultimately, in the problem, we have been asked to find the value of theta. So we'll have to use the right angled triangle, which is formed over here, in order to find that. So, okay. So here we know the length of the string is 0.6 meters. And if you take the center point as a reference, the distance will be from the top to the center point. So the h has to be subtracted from here. Fine. So that will give us the value of adjacent. So we have to take cos of theta, the value of which is adjacent divided by the hypotenuse. Adjacent value being 0.6 minus this height, that is 0.013. That needs to be divided by hypotenuse, which remains 0.6. The theta value we can take by taking cos inverse. We see here when we take the cos inverse value, we get the angle as 11.95. 11.95 degrees. So this is our answer for A bit. Okay, for the B bit, the conditions are going to be slightly different. Let's take the same situations here. The initial velocities are going to remain the same, but when it comes to the velocity of bullet, that's not going to be equal. So here, this will be equal. The final velocity of the bullet has been given as 10 meters per second, and it's moving, continuing to move in the same direction. Velocity v2, however, is unknown here. We'll have to apply the same formula, the conservation of momentum principle again, and we need to substitute the values here. So let's go ahead and substitute the values. Plus this becomes 0. On the other side, we have 0.01 times velocity v1, that is 10, plus m2. M2 is 2 kgs gross, and the velocity v2 is unknown. So this here we'll have to find the velocity v2. So when we substitute in the calculator, we get the velocity v2 as 0.45 meters per second.